Alright, even though we're in skill packet 9, we're going to refer quite frequently to the definitions of our trig functions, and I just cut and pasted those from the skill 8a, that the sign, given a point in the Cartesian coordinate system in x comma y, we use the Pythagorean theorem to define r as the square root of x squared plus y squared, and we do have that r will always be greater than 0, but this point C, x and y, this point C could be in any of our 4 quadrants, and therefore we define the sine of the angle theta to be y over r. We'll talk about reference angles in this skill packet 9 as well, just not right at this moment for this homework, but I am going to refer to this diagram as I go through and do the first 4 problems here in this video. So they want me to find the 6 trig values for a point that's in quadrant 3. The x and y are -3, -4, and the r is the square root of -3 squared plus -4 squared, and that's 5. This is your familiar 3, 4, 5 triangle. The sine of angle theta is the y coordinate divided by r, so that's -4 over 5. The cosine of angle theta is x divided by r, and that is -3 divided by 5. The tangent of angle theta is y divided by x, and that is a -4 divided by a -3, and the negatives cancel, so we just have 4/3. We can get our other 3 trig ratios by taking the reciprocal, or again just using the definition. Normally I think in terms of the reciprocal rather than definition, but the definition does say y over r, but we did have those reciprocal identities that describe the relationship between sine theta and cosecant theta. So this is -5 over r. The secant of theta is r over x, and that's -5/3, and the cotangent of angle theta is x over y, and that's all. The negatives will cancel, and that's 3 over 4. For the next problem, we have the x and y is given 4 comma -6 is down in quadrant 4. R is the square root of 4 squared plus, so 36 plus 16, is that right? 52, and then the square root of 52 is 2 radical 13. So my sine of angle theta is the y coordinate divided by r, -6 divided by 2 radical 13. That's, oops, pay attention to what I'm doing. Half of the -6 is -3. To rationalize this denominator, the cosine of theta is x over r, 4 over 2 radical 13. Rationalize the denominator. The tangent of angle theta is y over x, -6 over 4, negative 3/2. Shrink this up so we can give ourselves a little bit of room here. The cosecant of theta is r over y, negative radical 13 over 3. The secant of theta is r over x. square root 13 over 2, and the cotangent x over y, negative 2, is negative 6 over 4, which reduces to negative 3 over 2. There's our 6 trig functions for number 2. And number 3, negative 8, comma 4 is in quadrant 2. R negative 8 squared is 64. 4 squared is 16. Right? 80. And 16 times 5 is 80, so 4 radical 5. Alright, so I've got the sine of theta is y over r. The 4's cancel. Rationalize the denominator, and I get radical 5 over 5. Cosine of theta is x over r. Negative 8 over 4 times radical 5, so negative 2. Rationalize that. The tangent of angle theta, y over x, reduces to negative 1/2. Then the others are just reciprocals of these three. The cosecant of theta is r over y, which is going to reduce to radical 5. The secant of theta is r over x, negative radical 5 over 2. And the cotangent is x over y, which is negative 2. Then the last one on this video, 7,5 is in quadrant 1. All trig functions are positive in quadrant 1. (49 plus 25), 74, 49 plus 25 is probably 74, right? 74, what's it divisible by? Okay, so I can't simplify this radical, right? Because 2 times 37 is 70. I should have seen that. Okay, so I've got the sine of angle theta is y over r, 5 over radical 74. Rationalize the denominator. The man, this is not cooperating. The cosine of angle theta, x over r, the tangent of theta is y over x. Let's come in and shrink this up a little bit. The cosecant is defined to be r over y. We observe that that's the reciprocal of sine. The secant of theta is r over x. We observe that to be the reciprocal of cosine. And the cotangent of angle theta is x over y. We observe that to be the reciprocal of tangent. So I've got that. So I hope those helped. Talk to you later.